Oh yeah.
Yeah, but then you start dying too.
Okay, very good.
And you need to get it pen.
Well, you should have this. It's cold out.
Oh, my mom was like, it's gonna be hot today.
Oh, sorry. Thank you guys for letting me know. Alright, you guys better have 2 through 12 checked. Because the people who first had the cups are almost done. Once you have a circle, you're passing it somewhere. Just pass it over.
You made it. Okay, see if I'm right.
Oh, sorry, pass the cup. Keep the paper. Pass the cup. Keep the paper. Then, Carl, you can pass it up to Kevin. Colby gets another cup. Right, Colby gets another cup whenever David is done. It's okay, it's okay. We're working together, guys. Working together. Alright, first people with the cups, check 2 through 16. I'm scrolling.
Misty, I'm freezing.
Question, did anybody have any other answers for number 16 they want to check? Some of you might have gotten very creative. Anybody get very creative with the coterminal angles and add like 25?
No.
Oh.
Cold beef.
Alright, well, that's
Let me see it. There we go, cold beef. That's
a couple more seconds with those who first had the cups.
Doesn't look that straight.
Question. On number 16, well, okay, number 16A, they added 2 pi and subtracted 2 pi in order to get a positive and a negative coterminal. It worked out quite nicely. 1 positive, 1 negative. Add 2 pi, subtract 2 pi. On letter B, why did they add 2 pi and then 4 pi?
Because 2 pi would have minus 2 pi would have been positive.
Good. Janelle's saying because when you added 2 pi, you still had a negative. You had to get positive, so you had to keep adding. So you can add another 2 pi. You could have either added 2 pi from this one, or you could have added 4 pi from the original. But yeah, adding 2 pi wasn't enough. It was still negative. How would the math have told you that really quickly? How many fourths are 2 pi?
8.
Yeah, right? 2 pi are 8 fourths, so then, oh yeah, that's going to be still negative a fourth. Think of these whole numbers in terms of fractions. It'll help. All right, I think we're ready to go a little bit further. Although, you would think that this would be able to fit in one line. Negative 30 degrees in the 4th quadrant. Negative 750 was a bit harder. Can anybody talk through how they thought of negative 750? Do you guys literally go like negative 90, 180, 270, 360, let's do 36, 450, 540, multiples of 9, right? That's 54, 630, 70, 770. Oh, backtrack. Is that how you guys thought of it?
You could just do 360 times 2.
Good. You could think of revolutions of 360, right? So it's negative, people humming and singing. Thank you, but shush. Negative 360, and then negative 720, and then, okay, so go 2 times backwards, and then another 30. That's another good way of thinking about it. Anybody with cups, take a quick second, a quick pause of sketching. Check your 28A and B if you have not yet already. Good? Okay. Number 32. Complement, subtract from 90, supplement, subtract from 180. Oh, they even gave you degrees, not radians. They were so nice to you. Why is the complement not possible? Because it needs to be an acute angle, right? Something less than 90, adding up. Supplement was less than. Anybody with cups that has not checked 32, take a quick second. Check 32, are you good? Okay. All right, let me give you a second. There's 38, 44, and 52. I'll leave it there for just a moment. I think we're almost done with cups. Pass it, Caroline, I can get it. You can do it. Yeah.
Okay.
Good throw. All right, kiddos, if at any time during today's class, once we get started, you need more patty papers, you can come up and start again. I'll put the cups on that desk as well. Hopefully, though, we don't have too many mistakes.
Can I get a
Okay, people with cups. Actually, people without cups are still grading. Hold on, sorry. A little bit longer. Did you guys change to radians for number 52?
Oh, wait, no.
Sorry. For those of you guys that are already done grading, you're just chilling, or you don't have anything to grade and you're looking very contrite. That's not contrite. And I want you to think about, right now your circle has been folded into fourths, right? I wonder how you would fold it to get into eighths instead. People with cups, pause. I'm scrolling past 38. Did you get 38 okay?
Anyone want to get it?
I messed up.
Anyone need?
As you guys are grading number 76, if you have not yet, my question to you is, any questions on odds or evens? We might want to talk about degrees, minutes, seconds, I'm guessing. Although I think I gave you just odds for those ones. Put it on a desk. Okay, no questions besides degrees, minutes, seconds? You sure? Sorry, I'm taking it away. Anybody still checking?
There you go.
Okay, which one? Wait. Have I not opened? Oh. Sorry guys, I thought I opened your notes, but I guess not. Okay, did I hear a quick, I have a question? Yeah, Dean. Okay. Can you read me the directions to that one real quick?
The blade rotates at 5,000 revolutions per minute and find the angular speed between radians.
So angular? And that was 63?
Yeah.
Okay. Yeah, I agree, that one's weird. Alright guys, repeat against number 63 really quickly. The circular blade, revolutions per minute. Question, what is that unit talking about? Something on the outer side of the circle, how fast it's going, or how fast it's rotating? What is that? How fast the rotation is, or how fast the distance is changing on the outside of the circle? What do you guys think? Revolutions per minute. Yeah, rotations, because it's revolution. That's talking about a rotation around the circle. Okay? So, if they're asking for angular speed, does anybody know the units? Oh wait, they gave it to you? What units did they want?
Radians per minute?
Can I take revolutions per minute? Is there any way to relate revolutions with radians? Yeah. 1 revolution is 2 pi. So I could do just 5,000. Well, you could put the units if you want. Revolutions per minute, build a bridge. 1 revolution is going to be 2 pi radian. Remember, we don't usually write radian, but in this case we will because we want to show the angular speed. Yeah, so it'd be 10,000 pi radians per minute. For letter B, now it brings in another measurement. Now it says 7.25 or 7 1/4 inches is the diameter. Find the linear speed of a blade tip. What's the formula for linear speed?
R circle over line pivot omega.
That's arc length. Arc length equals radius times theta. We are going to use that idea. But what's the formula for linear speed? It's something over time. It's s over t. So what did I just find up here? Angular speed, isn't that theta over t? So how do I get s if I have theta over t? Well, Colby, you just told me s equals what?
R times.
So all I need is an R. Because if S is R times theta, I just need to get S over T. I can say it's R times theta over T, which means I can take theta over T, which is 10,000 pi, take theta over T times R, and wouldn't R be half of that? What's half of 7.25?
3.58.
Oh, 3 point. Not 5.8.
3.58.
Oh, I was just doing the decimal, sorry. Because I was thinking you could do,
3.7625.
yeah,
Mental math.
because it's 0.5 plus 0.125. And the units will be inches times radians per minute, but do we need to write the radians anymore? No. Remember, radian is an understood unit. We only write it when we have to worry about angular speed with theta over t. Okay? So just take your theta over t, or 10,000 pi, multiply it by the radius. And what we're doing is taking that as, seeing it as r times theta, seeing we already have theta over t, so just multiplying by an r. Okay. All right, good question. You guys did have some degrees, minutes, seconds, right?
We have one.
Just one? What number was that, Melanie?
49.
Okay. All right, kiddos, go ahead and open up your notes. We need to get there anyway. But we also had some degrees, minutes, seconds that we didn't get to finish. Oh, hey, Dean, good question. I had it totally ready to talk about too. Whoops. Whoa, go team. You read my mind. That's scary. Isn't this what number 49 was telling you to do? Take a decimal in, oh sorry, there was a degree mark. Don't worry about it. There we go. Take a degree and should change them to degrees, minutes, seconds. I think that's what 49 was telling us to do. I didn't go look at it, but I already made the screen big. I think it's having us go to degrees, minutes, seconds from degrees.
Yeah.
Okay, so if we need to do that, guys, what have I done so far? This is the example we didn't get to finish. I want to finish it now. That way you can go ahead and, if you haven't gotten to 49, you have an example to finish with. What have I done so far? Yeah, because how many whole degrees is in 14.326?
14.
But now I have a decimal degree. And that decimal, that's a fractional degree. Okay, I have minutes and seconds to deal with the fractional degrees now, to get more precise. Because if I round to only 3 decimal places, well, maybe that's not very precise. It may still have all these square miles to go searching for me lost in the ocean somewhere. To get more precise, let's go to minutes and let's go to seconds with that bigger decimal. Or maybe for their instrumentation, they can measure the minutes and seconds. The decimals of the degree would not be very helpful. So far, I set up a little baby conversion saying I need to get rid of the degrees and get to the smaller unit measurement, the minutes. So 1 degree is 60 minutes. Think of like 1 hour. Yes, I know minutes and seconds is a time measurement, but it's also a portion of a degree as well. So I cancel out the 1 degree. I need to multiply. Guys, what's 60 times 0.326? Oh my goodness. I'm going to teach you by hand. Ooh. Is it 1.9?
Shouldn't it be 0 to 0?
Oh, good call. So it's 19.56. Nicely done. Okay, so why did I split up the 19 and the 0.56?
If you can get to seconds.
But I can still go to seconds. I can still make it even more precise. Or at least I can get it into the other unit of measurement that they might be using. So far, 14 whole degrees. I figured out from that multiplication 19 whole minutes. And now what am I going to do to get rid of the minutes and get into seconds?
Yeah, multiply somebody 60 over 1.
Yeah, you can either multiply, well,
60.
you can only do 60, right? Because I already have minutes. So now I'm going to seconds. So I can go ahead and get rid of the minutes. And what's 0.56 times 60? Someone's already there, right? Yeah, 336. And that'd be 33.6, right? What do I do with the 0.6? Well, there's no smaller measurement than seconds. So. Unless they have some sort of microsecond, I don't know, but as far as I know, degrees, minutes, seconds, we'll stop it. Does anybody figure out how to use their calculator to do the same thing? Jack. Yeah, go ahead. I think it's plugged in. Nope, it's not. You might want to plug it in. Just because I'll show you, because I think some of the directions in your homework said something about a calculator. Meanwhile, if you guys haven't figured out how to fold it into eighths, maybe you're doing that right now. And you can be writing down section 4.2 and getting it ready. Unit circle. You guys have the decimal that we just did, 14 point, what was it? 14. 336? 326. 326, okay. Does anybody see the word angle in their calculator? Some of you have already found it, maybe. Where's the word angle? What button?
Never mind, didn't find it.
Or what?
Second
Second what?
Second apps. Hey, look, it's a degree mark. Yay, degree.
Oh.
Wait, but I need to change this degree. Oh, let's go look at that angle menu. I bet it's helpful. Do you see a little arrow? That means something like go to. And do you see a DMS? Ooh, I wonder.
What?
Dun, dun, dun. Uh-oh.
You got it wrong?
What's wrong?
We were totally off.
No, we weren't totally off. Hold on. Was I in radians and not degree? There we go.
Oh, okay, we did right.
Careful. What did I have to change?
To radian. I mean, to degree.
Yeah. So even though you put the degree mark, if you're in radians, it's still going to be confused. It still thinks of it as an angle according to your mode. But once we went to degrees, then it was good to go. Yeah? Now, here's the struggle. Ready? What if I wanted to check and make sure that it's right? I could do 14 second apps degrees. I could do 19 minutes. I'm just seeing if I can go the other direction. Every now and then there might be a problem saying go from degrees, minutes, seconds backwards. Here's what I want to show you. Guys, where's the seconds? I think it should be there, right? Oh, nope, that's an R. It's not. It's a second. Okay, so maybe like do 2 and then do 2 again. You could try that. Like that. It's a good idea, though. It's a really good idea, Abby. So, where's seconds? Just a hint, it's not in any menu. Look around your calculator. Can you find it? Yeah. Green alpha plus. Somebody said it's already there somewhere. I'm not going to make a whole new feature for it. So just go use the quote mark in the alpha characters. So they program so that when you use the quotations from the alpha characters in this context, context matters. Go bio class. They'll know. The calculator will know what to do. Does that make sense? Okay. So that's how you use your calculator. Let's go ahead and get into section 4.2. Let's go ahead and get into section 4.2. All right, you guys have your patty papers, right? I usually have one of mine that's drawn, but I don't think I have it today. Oh, it's at the very bottom. Poor little guy. All right, question. How'd you guys get it folded into eighths?
You put it back into its source and then you do it back. 8. Yeah.
Okay. All right. So, question. When I fold it in half, oh, mine's a little off, that's okay. When I fold it in half, question, how many degrees is that? 180, straight line, right? If I think of measuring from the standard positive x-axis all the way around. Okay, 180. How many pi is that? 1 pi. Okay, I need you to think of a circle as having two halves, right? And each of them are a pie. So you have pi that gets distributed up top, and then you have another pi that gets distributed down bottom. Now, why is that weird? Well, it's only one circle, but two pi. When you think about pi, what do you think of? Whew, that's cool. Somebody said infinity. Someone said 2. I don't know what
Someone said.
what? Snakes? Wouldn't have thought of that either. Go team. What else? Life of pi. Wow. All right, keep going. What else?
Thanksgiving.
Thank you. Okay. Circular pie. There we go. Circular pie, right? Pumpkin pie, apple pie. What else do you have? Pecan pie. Ooh, that's a good one. I'm so sorry. Have you ever had any sort of pie? No. It's like a circular cake, but with crust. Anyway. Yeah. How do you describe pie? It's goodness inside of your crust. Isn't that pizza? Really good. Sugar pie? All right, long story short.
Pie is a cake,
We need to have pie. Pie day, 3.14, March 14th. We'll have pie.
Yay!
Okay, ready? So you can think about like fruit pie, you can think about dessert pie, you can think about like mincemeat pie. Now we're getting kind of weird. Shepherd pie, even worse. Coming back. Or pizza pie. How about that, Abby?
There we go.
Okay, pizza pie. Abby's on board. Have you guys ever heard of pizza pie? No? If you want a pie in, is it Chicago? I think it's Chicago. If you want a pie, you're talking about pizza. So anyway, a pizza pie. Now, pause. Is a pizza pie or even a dessert pie or even a shepherd or a mincemeat pie going to help us remember that pie is a half circle? But what is a calzone? Okay, what's a calzone? It's a folded pizza with all the goodness inside. So, think of a pizza, it's like a big old Hot Pocket. Much better than a Hot Pocket. Okay, it's a pizza basically folded in half before it's been cooked with like a little around the edge and then, okay. I think I need you to think about pies in a calzone, okay? All right, I want you guys to get your calzones folded in half. It's a pizza folded in half, literally. If you haven't had one, go have one. At a place with good Yelp reviews, otherwise you might just have a really sad first experience. Okay, so. Fold it in half. Calzone. True? Okay. So if this is one pie, if it's one calzone, then question, where's pie over 2? Pie over 2. Take the calzone and cut it in. Oh, that's easy. Pie over 2, he's 90 degrees, right?
Yeah.
Cool. All right. What if you had your whole calzone and now I want them cut into fourths? What would you do? Okay, fold it in half. There's half a calzone, then fold it in half again, right? Now I have pie over 4. Right? Fold it in half again. You gotta pinch the corner, make sure it's all lined up. If you guys were folding into 8ths, that should have been where you went. It's an 1/8 of a circle, true, but it's a 1/4 of a calzone or a pie. Right? Now, don't go to 16ths, because actually the unit circle doesn't have 16ths. Question, what angle is 1/4 of a pie, 1/4 of a calzone, or half of a 90? Oh, there you go. So when you unfold your calzone, now you have 45 degrees marked, right? Okay. But in radians, it's so much easier, because the other one's like, okay, 45 plus 45 is 90, 90 plus 45, let's see, 135, 135 plus 45 is 180. It's so much easier in radians, because how much of a 1/4 is one, well, let me start on this side for you guys. How much of a 1/4 is this one right here? How much of a 1/4? How much of your calzone?
A 4th.
A 1/4, that's a 1/4, right? But what if you have 2/4?
A half.
A half. What if you have 3/4?
A 3/4.
What if you have 4/4?
A whole pie.
So it's pi over 4, pi over 2, 3 pi over 4, and 1? Good question. What if we have 2 calzones back to back?
It's a pie.
So I have 1 pi over 4, right? 1/2, 3 pi over 4, 1 whole. What would this one be? If I had all of these and another one. Well, wouldn't that be 1 1/4? But what is that as a fraction? 1/4, 2/4, 3/4, 4/4. This would be 5/4. This one would be 6/4, or 1 1/2, 3 halves. 6/4 reduces. The next one would be 7/4, and the next one would be 8/4, which reduces to be 2 calzones, 2 pie. Right? I want you guys to go ahead and get your circles, and I want you to trace the lines.
It's the same thing.
Oh, we don't have all of them yet. It's okay. Let me get rid of the green ones. Alright, trace your lines. You guys should be able to, if you have an ID card or a credit card or the edge of your calculator or, the edge of your composition notebook. You can use that too. Trace the lines.
Of looking at the point you want
0, 180.
to draw. No.
Just use these ones.
Okay.
So trace. So you guys are tracing the 0, 180 line, or the x-axis. You're tracing the 90, 270 line, or the y-axis. And then you're tracing the folds you just made along the 45s. But what you're doing is you are cutting your calzone, your pie, in half and then in fourths, all the way around the circle. Put 2 calzones together and you have a circle. Put 2 pie
So you
together
want
and
us us
you
to
have
trace the x-axis and the y-axis?
x-axis, y-axis, and then the pi over 4 lines as well. So hopefully all the folds that you've made so far. And then, you should have a little bit of space around your circle. Label all of those angles. So 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 6 pi over, 3 pi over 2, 7 pi over 4, and then back to the beginning, 2 pi. All it is counting by fractions, all it is. 1 fourth, 2 fourths, 3 fourths, 4 fourths, 5 fourths, 6 fourths, 7 fourths, 8 fourths. I know, pen start takes
It
time.
gives you work, man. We don't have to go to the first one. And then I got distracted and stuff. And then the one.
I can see and show you all
Go ahead,
of
man.
them.
You now know
Now, if you guys finish tracing, you can start thinking of how on earth are we going to get those pi over 6s? And it's not by cutting the pi over 4 in half, because 45 cut in half is 22.5. Ew, gross, that's not special. Ooh, I need to cut my calzone into 6ths, which means I need to cut my half calzone into thirds. And cut my 90 into thirds. How are we going to do that? How do we fold it into thirds? We can't just fold the half into half. That would be
22.5.
fourths. We cut it into thirds. We don't want 22.5. We want 30 and 60. This is where it's going to take some coordination. We'll put it that way.
what's coordination.
Good question. I never had much of it either. Wish I would have made ball handle it easier. I'm going to try something new this year. I'm going to see if it helps. But I have to get everybody on the same page. I want everybody to get to their 90s. Everybody get to your pi over 2s. Your calzone cut in halves. Once you get your angles written down. Get to your 90s. And be holding or pinching the center. I think that's where Abby went wrong on that one. Oh, it looked really cool. Pinch the center. So have your circle on the outer. Pinch the center. Once you have your angles marked, pinch the center. And wait till everyone's eyes on me because this is where I start to lose half of you. Usually guys, sometimes girls do.
Wow.
No, that wasn't it. That was just factual. Okay, get to your 90s, not your 45s. Not your 45s, get to your 90s. I'm just gonna try and make it work. Looks okay. Fold it in half, fold it in half again.
Ryan, just put it down.
No, I'm checking. This is good.
I did it wrong like a few steps ago.
Well, that's okay, it just looks cool. Abby did it too. But you can still just trace just don't trace the outer folds. Those just look cool. Trace from the center. Just trace those lines. Yeah, that's what Abby did.
Yeah, right.
Do we put this?
Alright, kiddos, you're pinching the center? Alright, everybody pause because we have to get the fold in. So everybody fold it into 90. Just pause, it's okay, you can trace in a second. Fold into 90, pinch the center. We'll get back to tracing. Alright, ready? Here's what I want you to do. I want you to try to take your index finger, and I want you to try to put it over the 45 that you just traced. Put it over the 45, roughly in the center. Okay? You got it? Take your other finger, and I want you to try to fold the patty paper. Ready? Fold one and another. You're making a little finger burrito. Little finger burrito, okay? Your finger's on top of the 45, a little finger burrito. Now, all of our fingers are a little bit different, but just get the finger burrito where you have one folded in and the other folded on top.
Oh.
Maybe like a cannoli. That might be a better way of describing it, but maybe they're right. Or a pasta shell. Well, it's not, I don't know, it's not a burrito. Burrito's okay, now ready? Kind of pinch it, pull your finger out. Now wait, just hold it. Hold it, hold it. Ready? Here's what you need to do. You need to go ahead and squish those two sides in to where they're perfectly overlapping, coming to a point to where you have, ready, pause, on the bottom, 1/3, in the middle, another third, and on the top, another third. You need 3 layers all together. It's like a little bugle. Like a trumpet. You gotta kind of like wiggle it, until you have only 3 layers, 1, 2, and 3. If you can get it to where the 45 is in the center, and these ones are wiggled in, and you have only 1, 2, 3, well I guess this one, but I mean, this one's like 2 and 1. But you have 1 layer, 2 layers, 3 layers, and you can squish it. You just got your 30 and your 60. Gotta make it come to a point. Gotta make it come to a point.
Wait, I don't know if I did that right.
No, I'm just winging it.
Gotta make it come to a point.
Is that it?
Yes,
I think it's it.
I'm lost.
Gotta get it to come to a point.
So you roll it like a.
Take it here. Go half. Make a burrito. Make it like a taquito. This is a taquito. This is not a burrito. I assure you. And then you take your finger off and then you close it. How do you? I think I got it. I mean, these are my lines. What'd you do? Right there. Right there.
I put it here.
That's pretty decent.
Cal goes right there.
And then pull my finger out, and then I just kind of like close it until it's focused. Yeah, and then you just kind of like gravel it up. Just roll it until this comes to like a point. Just squish it. Is that it?
Do we trace the third line?
Yeah.
Wait a minute, what the heck? What'd you do to my paper? Angela, let me see yours. Colby, what have you done? That's okay.
Stabbing off the thirds.
Oh, they ruined it.
I think you did. This deep.
Wait,
Do I need to put this
the
down?
way you did it did not make it false. You made a stop.
I can just approximate.
The folds are not green.
I love it. It looks so clean and then it gets so messy. Yeah, Colby, you kind of messed mine up.
What'd you say?
How did I mess yours up?
I don't know, maybe because like one line is overlapping with the other. Until the 45. Exactly, that's what I have to do.
Guys over here done it.
Miss D,
All the guys over here done
Yeah.
why didn't you just say to make it to the 45 and then fold the lines until they meet the fold?
I've done this a lot of years.
Is that not
Way
right?
worse. Yeah, ready? Okay.
I have a way. I have a way. Just print that
Print them out and balance cut.
Yeah, I would have It's awesome. I don't know where my shirt is. Abby is selling your shirt.
Switch. So guys, if you want to help, you ready? Pinch. What you need is you need the 45, and you need one side to go a little bit past the 45. The other side come in a little bit past, and you're wiggling it until they seem to be equal with that 45 in the middle, making it come to a point to where they're all about lined up. So I have this, I have the edge, and then you squish it. Worst comes to worst, you can just open it up and say, well, you know what? I want lines that look kind of like this.
Wait, yeah.
So mine look like.
There you go. If it helps,
It helps.
if it helps, you can always just open up and say whatever, I'll just make the lines myself. Yeah, if worst comes to worst. Yeah, that's nice.
Congratulations.
Jack, you get that?
Alright, if the fold didn't work, no stress.
The boys did it.
Just trace little lines on either side of your 45s, but not in the middle. Not in the middle. Of the 45. Here's the long story short. You ready?
Yeah.
The long story short, it's okay. We'll trace these lines.
Oh, so there's the.
We just cut the calzone into sixths. Now remember, calzone's just half, right?
Yeah, I do that.
Ready? You just cut it into sixths with that last fold. Because you have 1/6 pi over 6. 2/6. Wait, what's 2 over 6? 1/3, right? 2/6. 3/6, which is 1/2. 4/6, which is 2/3. 5/6, which is 5/6. And then 6/6, which is 1.
Yes.
It's all fractions. 1/6, 2/6. Oh, that's a third. 3/6, that's a half. 4/6, that's 2/3. 5/6, 6/6. And how do you finish? Keep adding. 7/6, 8/6, 9/6, 10/6, 11/6, 12. Just reduce as you go. Yeah, it does look good. Now, long story short, if you feel like this whole thing was a fail, right? You can still trace this circle into your notes, and you can borrow a cup when you come in tomorrow, or you can take one right now and just trace the circle in your notes. The rest of you guys will tape it in, or glue stick it in, either way.
I remember not in a perfect circle.
Oh, you got it? Okay. Yeah, nice.
Mine's close, it just doesn't go all the way
I'm
across.
impressed.
No,
Now, what was the whole point? The whole point is that all the radians that some of you guys worked so hard to memorize last year, all it is counting by fractions. There's no need to memorize besides the fact that you're portioning a calzone, a pie, into sixths, into fourths, and into thirds. And in the process, technically, sixths and fourths. Sixths and fourths. In the process, you end up getting the thirds and the halves at the same time. Now, if you want, I'm going to start passing you a glue stick. If you want to get it in your notes, that's not a bad idea. At some point.
Do you put it at the top or like?
You can put it right under the other page of notes that we took, which was this one.
Wait, do we have to put it in our notes or can we keep it like?
You can keep it out if you want.
what do you think?
If you don't want to, you just have to lose it.
Thank you.
You can put it right underneath the notes.
Nope.
Okay, kiddos, here's the deal.
It's a secret island in the Himalayas.
Here's the deal. When you shade, if I was to take one piece, that'd be 1/6 of my calzone, 1/6 of my pie. Or if I were to shade a pie over 4, do a lighter one. Or if I was to shade a pie over 3, is all of these form the three special triangles from geometry. Either the 30-60 degree, or the 45-45, or the 60-90. And with each of those special triangles from geometry, which is why we only use the sixths, the fourths, the thirds, we can go ahead and come up with our trig ratios, basically using those special triangles from geometry, where the 30, 60, 90 had ratios of 1, 2, root 3. The 45, 45 had ratios of 1, 1, root 2. And then the 60, 30 have ratios of 1, 2, root 3. Except, you guys aren't used to those numbers being in the unit circle because a unit circle has a radius of 1. Well, hold on, all of these have different radii of 2 and root 2 and 2. That doesn't work. They don't fit in the unit circle, except if I scale it down, similar shapes have proportional sides. If I scale it down to fit into the unit circle, all of a sudden my radius is now been cut in half, or I should say my hypotenuse has been cut in half, so is everybody else. My radius has been cut into root 2 of, well, into root 2 over root 2? Has been divided by root 2. And then this one, they've all been cut in half again. Now we rationalize this one, so this one becomes root 2 over 2. But these are those ratios that you probably remember from last year. But here's my way of remembering it. Over a little or over a lot? The pi over 4s are always going to be root 2 over 2. Because the pi over 4s are isosceles triangles, the two sides are equal. So the x and the y, which is going to be the sine and the cosine, are going to be the same. Pi over 6, though, the x is longer, so he's going to have the root 3 over 2, whereas the y is shorter, he's just going to have the 1/2. Pi over 3, though, is switch. It's over a little, up a lot. So the x is going to be the small one, the y is going to be the big one. And besides that, all we need to think about are our nice little 0s, 90s, and 180s, where the furthest you can go over is 1, the furthest you can go up is 1. And then all we have to think about to get all the way around the unit circle is all students take calculus. Or all are positive, sine is positive, tangent is positive, cosine is positive. And play with the signs. But kiddos, what I want to get ingrained into your head today is that 30s, 45s, and 60s are all just fractional pieces of pi. If we add up the fractions, we'll get the unit circle. Tomorrow, we're going to play with the unit circle. We're going to get all the rest of our ratios down. And we're going to see if we can start getting you guys to the point where you will have this down solid for the rest of this year and next year and the rest of your life. You can have that. For the rest of your life. Bye, guys.
Yeah, I'm gonna go right now.
Yes.
I'm missing a couple.
Oh, yeah, I will.
Oh, thanks, Dean. Let's do it from there.